Next, we discuss several examples taken from the past year final exam. So this is the first example. This is the MOSFET, and this is a common gate. This is a common gate circuit. Okay, and then the circuit is given, and also this is the ID versus VGS graph. So we have one curve. This is the transfer curve. Okay, this is transfer curve, and then this straight line, the linear line, this is the KVL at input loop. Okay, so this is the question. The question is determine the VGSTH, IDQ, VGSQ, and K value for the MOSFET. Okay, for the first question, you asked to determine or identify what is VGSTH, IDQ, VGSQ, and K value. Okay, the first question, you can get the answer from the graph. So for example, what is VGSTH? The VGSTH is the threshold voltage. So you need to see the transfer characteristic. So this threshold voltage is the point where the current start to flow. So this will be the 1 volt will be the VGSTH. Okay. And then the IDQ and VGSQ is the Q point. So the Q point is the intersection between the transfer characteristic and the KVL. So this is the intersection. The value for the ID at the intersection, this is the 2.9 milliampere will be the IDQ. This is the IDQ, and 2.1 volt will be the VGSQ. Okay, so we have answered the VGSTH, IDQ, and VGSQ. So, and then next one is how to calculate the K value. So for the K value, you can use the value of IDQ and VGSQ to calculate the K value. So let's say we have this one is the K. The equation for the K is K equal to IDS on over VGS on minus VGS TH square. So here ID on and VGS on, we take the value at the Q point. So ID on is 2.9 milli, and then VGS on is 2.1 volt, VGSTH is 1 volt. This will give you the K of 2.4 milli. The unit of K is ampere over V square. Okay, so we have solved the first question. Okay, how about the second question? Determine the value of VSS, RS, and transconductor CM. So the VSS is not given, as well as RS is not given. So for the question number 2, we need to use the KVL at the input loop. Okay, so this is if you see the this circuit. So for the KVL, actually we are doing the DC analysis. When you do the DC analysis, what you need to do, you need to remove the capacitor and all of the other components connected to the capacitor. So this will be removed. So and then you will only have VSS, and then you have here this is the RG, so this is also removed. This is your RD plus VDD, and this is the RS. Okay, so this is the circuit for the DC analysis. We remove all the C1 capacitors, C1, C2, and C3. Okay, what remain in the circuit is just these components. Okay, then for the KVL, so we want to use the input KVL at the input loop in order to solve the RS and VSS. So the KVL at the input loop is the KVL that passing the gate and source. So this is the gate. So the KVL, this is the KVL of the input loop. Okay. This is the KVL at the input loop. If I write the KVL at the input loop, okay, if I write the KVL at the input loop, so we start from this RG. So the current at the RG is IG, and then the RG is 50K. Okay, and then plus the VGS. Okay, VGS, and then plus the current at the RS is ID. This is ID RS. RS is unknown, and then we come to the minus VSS to 0. Okay, for IG is equal to 0, so this term is equal to 0. So you will have the KVL is VGS plus ID RS minus VSS equal to 0. Okay, this is the KVL. Okay, so you need to compare this equation, the KVL, with the drawn graph. This is the graph. Okay, so let's use this the maximum current, ID current here. Okay, this is the sorry, let's use this we call it the cut-off point here. So this is called cut-off point. So cut-off point here is when the ID is 0. So when ID is 0, the VGS is equal to 5. Okay, so the statement is when ID is equal to 0, so VGS equal to 5 volt. Okay, so we insert this condition to the KVL, so you'll get the VGS is 5 volt, ID is 0, minus VSS equal to 0, so you get VSS is equal to 5 volt. So this is the answer for VSS. And then the second condition is we use the saturation point. So this is what we call a saturation point. Okay, saturation point is the ID is 5 milliampere when VGS is 0. Okay, or when VGS is 0, ID is equal to 5 milliampere. So you put this condition into the KVL. So VGS is 0, 0 plus 5 milli RS, and then we already know that VSS is 5 volt, 5, and then the source is RS is equal to 5 over 5 milli equal to 1 kilo ohm. This is the solution for the question number 2. Okay, so we have done this number 2. We missed this is VSS. We have calculated VSS, RS. Okay, how about the transconductance? So for the transconductance, you know that the ID, you know the ID, and you have calculated the K. So the IDQ from the graph, the IDQ is equal to this 2.9 milliampere. So IDQ is 2.9 milliampere. So the transconductance GM is equal to 2 times square root K IDQ. So this is K is 2.4 milli, 2.9 milli. Okay, this calculation will give you the GM value of 5.28 millisiemens. Okay, so we have all the answer. Transconductance, we know the transconductance, we know the VSS, and we know the RS. Okay, this is we have done the second question. Okay, and then the third one is draw the small signal equivalent circuit at the midband. So the circuit, this is a common gate. This is a common gate. Okay, let me okay, the equivalent circuit is you replace the capacitance with the short circuit. So this is the short circuit, this is also the short circuit, this is also the short circuit. So because this is short circuit, so RG will be disappear, and then the DC circuit is ground, DC source will be replaced by the ground. So this is also ground. So at the end you get this one is the equivalent circuit. This is your VS, this is the R signal. So you have here, this is the RS. Okay. For the common gate, we will use the slightly different arrangement for the hybrid pi model. So it will you use the T shape of the hybrid the model, T shape model, T shape of the model. So it will looks like this. This is positive, this is the VGS. Okay, this is the source terminal, this is your GM VGS, this is the RD and the load. Okay, so this is the answer for the equivalent circuit. Okay, the last question is calculate the value of the drain resistor RD if the midband gain, voltage gain, V out over V in. So V out over V in is equal to 21.58 dB. So it's given that the AV, which is V out over V in, is equal to 21.58 dB. Okay. So first you need to convert the dB to the ratio, unitless ratio value. So this is equal to 20 log modulus AV. Okay, modulus AV. So the AV is equal to 10 power of 21.58 over 20. Okay, so this is equal to 12 times. So the gain is 12 times. The gain is the 12 times. Okay. So in order to calculate the RL, we need to derive what is AV. So AV is V out over V in. So the V out is equal to minus GM VGS times RD parallel with RL. So GM, we have calculated the GM. The GM is 5.28 milli. And then we know the VGS. The VGS is the variable. Okay, RD is unknown. RL is 4K. Okay. How about the V in? V in is equal to minus VGS. So from this V out and V in equation, the AV equation is equal to 5.28 milli RD parallel with 4K. So this is equal to 12. Okay, from this relationship, you get the RD parallel with 4K equal to 2.27 kilo ohm. So this is RD 4K over RD plus 4K equal to 2.27 kilo. So the solution is RD equal to 5.25 kilo ohm. Okay, so you obtain the RD value. So we have finished the solution for the example number 1.